Alright, for this recording, we'll be answering this question 3 coming from the NCV 2024 supplementary paper 2. So this question 3, it's all about general trigonometry, your cosine, sine rule, and the area rule. We're also going to be discussing identities and solving trigonometric expressions. So let's look at 3.1, which is a multiple choice type questions. Alright, so here we are given various options for each question. So 3.1, we have various options that are given as possible answers to the following questions. Choose the answer and write only letter A to E. So you have to choose between all the given letters here next to the question number in the answer book. So here, if you take a look at 3.1.1, let's start with this one. So here we are given a formula. This is a reduction formula, right? This is a reduction formula. So you know, with reduction formulas, we always have to apply or use the cast diagram, right? So this is our cast diagram. In the fourth quadrant, we know that cos is positive. First quadrant, all the trig ratios are positive. Second quadrant, sine is positive, and then the fourth quadrant, only tan is positive. So we have how many reduction formulas do we have? I think it's 3. In the second quad, we have 180 minus, third 180 plus, and then the fourth quad we have 360 degrees minus theta, right? So here we have tan 360 minus x. This 360 minus x is found where? In the fourth quadrant. And in the fourth quadrant, sine is negative, right? Because only cos is positive in the fourth quadrant, right? So everything else is considered or taken as negative. So in order to solve this reduction formula, we're gonna get a negative tan x, right? So this is the answer to this formula, right? So after solving this, we can now start looking for the correct answer here, right? So we can see that the correct answer is what? It's gonna be C, which is the minus tan x. So this is how you should treat all multiple choice questions. Start off by solving whatever is given. Then the answer that you got, then you can just compare it with the options that are given, right? So for 3.1.2, we have a minus sine 180 degrees plus x. So 180 plus is found where? In the third quadrant. So this we can solve as, so the negative sign remains. Then we're going to focus here on the sine x plus sine 180 plus x. So 180 plus, it's a reduction formula in the third quadrant. So in the third quadrant, only tan is positive. So solving this produces a minus sine x, right? So this is negative sine. This negative multiplied by that one gives us a positive sine x. So given these options, we can see that our answer should be A. Another reduction formula here, right? Don't get confused, guys. Do not get confused. We have reduction formulas. A reduction formula, it's a formula that will always have 180 degrees or a 360 degrees. And we also have another set of formulas that contains 90 degrees minus and the 90 degree plus. These are co-ratios, right? These are co-ratios. This is a totally different story compared to reduction formulas, right? So, but it's unfortunate that in this question we don't have any co-ratios, right? So don't confuse the two formulas. Ne? The co-ratios, we solve them differently compared to the reduction formula. So another reduction formula in 3.1.3, cos 180 minus x. Where is this found? Second quad. This formula is found where? In the second quadrant. So in the second quadrant, there's only one ratio that is positive, that is sine. Everything else is considered or taken as negative. So the answer here is going to be a minus cos x. This is the resolution to this expression. Is what? It's minus cos x. This is the actual answer. Now you are given four options to choose from. A is out of the picture. B is our no, it's out of the picture. And then C as well. So it seems like our answer is what? Is D. Going to the 3.1.4. Now we are working with something totally different, right? So for the first three questions, we were given reduction formulas to solve. 3.1.4. To solve this, I think it's obvious that there's like a common factor here. There's a common factor. I see a common factor, which is what? 3. Let's take it out. Remember, we are simplifying here. So we're going to start off by taking out the common factor, which is 3. So this is sine squared y plus cos squared y. This is what remains inside the bracket after taking out the 3 as a common factor. So sine squared, cos squared, sine squared plus a cos squared. This is an identity, right? This is a squared identity. A squared identity that produces a 1. So sine squared plus cos squared, that gives us a 1. So 3 times 1, that is 3. So B is the answer to this question. Okay, 3.1.5, it's quite of a tricky situation, but we can solve this one by doing this. Let me take this down. I don't need this anymore. Okay, so 3.1.5, we have this. 1 over the square root of 3 tan alpha minus 1 equal to 0. Okay, we're gonna apply the same idea that we applied for the rest of the question. Start off by solving. So the first thing we're gonna do here, obviously, is to get what? To work out what alpha is. So I'm gonna take the minus 1 and transpose it to the right hand side. I'm solving this trigonometric equation. This is an equation, by the way. We have the 1 on the right hand side and it's positive. Then I'm going to try to make the tan alpha the subject of the formula. So what do? I'm going to multiply by the multiplicative inverse of this, which is going to be 3 square root 3 over 1. What I do on the left hand side, I also have to do it on the right hand side. Over 1. This cancels out this, the 1 cancels that. I'm left with a tan alpha equal to the square root of 3. Now let's calculate alpha. Alpha is equal to arctan of square root 3. Let's work this out. So on your calculator, you're going to start off by punching the arc of tan square root 3 equal to, I'm getting a 60 degrees. So my alpha is equal to what? 60 degrees. Well, when solving trigonometric equations, right, you're always gonna look at the value. The value that is equivalent to the trigonometric ratio in question. So I have tan alpha that is equal to some value here, right? So the sign of this value, it's positive. So when solving for trigonometric ratios, you always check where the value is positive. If it was negative, I was gonna check where I was gonna check the quadrants where that trigonometric ratio is negative. But in this case, it's positive. So looking at the cast rule again, cast rule, where is tan positive? First quad, and where? Third quad, right? So now looking at the options given, looking at these given options, for A, we are told that if this is given, right, then tan alpha is negative. This is not true. We simplified and we saw that the tan is actually not negative, but it's what? It's positive. Let's check out B. B tells us that alpha is in the first quadrant and the second quad. Okay, that is not true. That is not true. That is not true. Yes, alpha is equal to 60 degrees, and 60 degrees is an acute angle. I have a 90, a 0, 180, and a 270 here. Goes back here to 360. So alpha is 60 degrees and an acute angle, where it's located in the first quadrant. And they are also saying that alpha is also in the second quadrant. Well, the alpha cannot be in the second quadrant, right? Remember, a trigonometric equation will always produce a set of solutions. Like in this case, before we conclude on B, let me provide the actual solutions to this equation, right? So since tan is equal to a positive square root of 3, you're gonna ask yourself this question: where is tan positive? It's in the first quad and the third quad. So we have two solutions, one in the first quadrant, that is gonna be alpha equal to 60 degrees. Where else is tan positive? In the third quadrant. In the third quadrant, right? In the third quadrant. So in order to get the solution in the third quadrant, you're gonna apply, or you're gonna use the ratio, I mean the formula, the reduction formula that is found where? In the third quadrant. In the third quadrant, we have 180 degrees plus theta. So in the third quadrant, alpha becomes 180 plus this 60 degrees plus 60 degrees. I'll explain, I'll elaborate further on trigonometric equations once we get to, I think it's question 3.3 if I'm not mistaken, in this same question 3. So alpha now becomes what? 180 plus 60, it gives us what? A 240, right? So this explains why B cannot be the answer, because alpha is in the first quad and the third quad, not the second quad, right? It has to do with the sign of that value. So alpha is in the first and third quadrant. So C is our solution. C is the answer here. And then D also cannot be the answer because alpha is not 30 degrees. Alpha is in the third and fourth quad. This is also wrong. So our answer is C here, right? Okay, let's jump to the next one. Let me just erase this. Maybe I can put this back on. Second part of the question is this. Maybe if I can drag this down. Yep. Okay. So 3.2, we have a bit of a situation here. So they want us to solve without using a calculator. So without using a calculator, evaluate the following and show all the steps. So with this type of question, where you have to solve without using a calculator, you will be given obtuse angles, right? You will be given trig ratios with either obtuse angles or reflex angles. Those angles you'll have to reduce using reduction formulas to special angles. I hope you know this, guys. We have how many special angles? 3. 30 degrees, 60 degrees, and a 45 degrees, right? So these are the three angles we have: 30, 60, and 45. These are the special angles. So the reflex angles and the obtuse angles we have to reduce using reduction formulas to special angles. When you are given a question where they want you to solve without the use of a calculator. Okay, so going back to cast rule. So this is our cast rule. So cast rule, since we want to focus on the reduction formulas here, so let me put this back. Let me put the angles on the cardinal points of the Cartesian plane. So this is what we have. But our reduction formulas are 180 minus theta, 180 plus theta, 360 degrees minus theta. So these are the reduction formulas that we have in three quadrants: second, third, and fourth, right? Now, equal to, we're going to start with this one, tan 240 degrees. So how do we reduce these obtuse and reflex angles to special angles? So we're going to ask ourselves, where is 240 degrees found on the Cartesian plane, right? In this cast diagram. So 240 is found where? In the third quadrant, right? In the third quadrant. So this tan 240 degrees, actually we'll have to write it as a reduction formula. We're going to reduce it to this 180 degrees plus, I think it's what, let's see, 180 minus 240, I think 60 degrees. So it's going to be 180 degrees plus 60 degrees. So you want to write the 240, right, as a reduction formula, so that when you write it, it gives you the 240 back, right? So 180 plus 60, it's what? It's 240. So you want to express the 240 as a reduction formula, right? So it's sort of like it's going to be a sum, or it's going to be a sum or a subtraction between the formula and a special angle. So you are basically writing it as a reduction formula, right? But the theta, it should be what? A special angle. So 180 plus 60 gives us 240. Let's continue. Let's go to the cos 330. So 330, where is 330 found or located? It's located in the fourth quadrant. So 330 is found in the fourth quadrant. So how do I write 330 as a reduction formula? So we know that in the fourth quadrant we have a reduction formula that is 360 minus some acute angle. That acute angle must be a special angle. So 360 minus theta. So 360 minus 30 gives us a 330. Let's continue. So the sine 135 is found where? In the second quadrant. So 135 in the second quadrant. How can we write this as a reduction formula? It's going to be a 180 degrees minus 45. So 180 minus 45 gives us a 135. Continue. So we now have this cos 225. So 225 is found where? In the third quadrant. So 225 can be written as 180 degrees plus 45. But let's double check this. So 225 minus 180 gives me what? 45. So yes, 180 degrees plus 45 is definitely a 225 degree. Minus sine 210. 210 again is found where? In the third quadrant. So I'm thinking it's going to be 180 degrees plus 30 for sure. 180 plus 30 multiplied by cos. Multiplied by cos, let me write it down here. Multiplied by cos, cos to 10, 120 I mean, minus 120, that's 60 degrees. So 120 is found where? In the second quadrant. So in the second quadrant, the 120 will be written as 180 minus 60 degrees. Right? Now we can solve these formulas. 180 plus is found where? Third quadrant. And in the third quadrant, tan is what? Is positive. So it's going to be a positive tan 60 degrees multiplied by cos 360 minus 30. Where is this? Fourth quadrant. So in the fourth quadrant, cos is what? Is positive. So it's going to be a positive cos 30 degrees divided by sine 180 minus 45, second quad, and then in the second quad, sine is positive. So it's going to be a positive sine 45 degrees multiplied by cos 180 plus third quad. So in the third quad, cos is negative, so it's negative 45 degrees minus sine 180 plus, this is going to be a negative sign because in the third quadrant sine is negative, so it's negative 30 degrees. And then we now have 180 plus cos 180 minus, so it's minus cos 60 degrees equal to, okay, so we're now gonna need this. We're gonna need our triangles. We're gonna need our triangles for special angles to solve this. All right, so 90, I think it's gonna be 2 square root 3 1, and then 60 degrees 30 degrees 45 1 1 2, I mean square root 2. Okay, so tan 60 degrees tan, it's opposite over adjacent, so here it's going to be the square root of 3 multiplied by cos 30 degrees, now 30 degrees, so it's adjacent over the hypotenuse, so it's square root 3 over 2 over sine 45, so this is 45 sine, it's opposite over hypotenuse, so it's 1 over the square root of 2 multiplied by minus cos 45. Here's 45 once again, adjacent over the hypotenuse, it's 1 over the square root of 2 minus negative sine 30 degrees sine 30, it's opposite over hypotenuse, so it's a half minus cos 60 degrees, this is 60 degrees adjacent over hypotenuse, so it's another half. Okay, so multiplying this, divide this by 1, square root 3 times square root 3, that's 3 over 1 times 2, that's going to be a 2, divided by 1 times 1, it's 1, square root 2 times square root 2, that's a 2, but don't forget the negative here, so just put it here, and then it's going to be a minus open bracket, this negative times that negative, it's a positive, 1 times 1, that's 1, and then this times this gives us what? 4, gives us 4. Am I missing something? Am I missing something? So this multiplied by that, yes, this times this, it's 4. Alright, did I miss something though? I feel like I did. Okay, let's see. Sine 45, let me check something, man. I did this calculation. Why am I getting a 2 here? So sine 45, that's 2. That's 2. That's 2 square root 2 over 2. That's gonna be a 4, then a 2. Okay. Oh, okay. No worries. No worries. No worries. Okay, so we're gonna continue now. We're gonna continue with this calculation, but I'm subtracting two fractions here, right? So when I'm subtracting two fractions like this, I'll have to get these denominators the same, right? I have to get these denominators the same. Or, you know what, let me just say, I don't know how you're gonna approach this, right? How you're gonna solve this, right? But I think it's, you know what, we're just gonna say 3 over 2 over, then we're gonna solve the denominator now, right? I don't want to complicate this one, so it's gonna be minus 1 over 2 multiplied by 2 over 2 minus 1 over 4. The idea of multiplying by a 2 over 2 is just to get the denominators the same for the two fractions. So it's going to be a 3 over 2 divided by minus half times 2 over 2. So the 2 times the 2, the 2 times the, the 2 times the 1 over the numerator, and the 2 times the 2 over the denominator. We now have a 2 over 2 times 2, that's 4, minus 1 over 4. Continuing from this side, we have a 3 over 2 dividing minus 2 minus 1 over 4. Now the denominators are the same. What do? We just subtract or just add the numerators. Now we have a 3 over 2 over negative 2 minus 1. That's negative 3 over 4. Continuing, we're now going to have to do what we call a tip and times. I have a fraction that is being divided by another fraction. So it's 3 over 2 multiply minus 4 over 3. This cancels this, and then we are left with what? A minus 4 and the 2. So minus 4 over 2 gives us what? A negative 2 as an answer. So this is the final solution to the 3.2. If there's any question that you have, you can just drop it in the comment section of this video. Now let's jump to the second part, 3.3, where now we have a question on identities. This is a question on identities, where we have to prove that the left hand side is the same as the right hand side. So here they want us to show that this is equal to this. So we can see that the left hand side calls for further simplification. So an identity is simply taking the side with the most stuff, or that side that requires simplification. It's evident that the left hand side, there's some work to be done here. So tan x, let's take that, cos over 1 plus sine x is equal to, so this tan is going to change to a sine x over cos x. Why am I changing this to this? Why am I changing the tan to this? Remember, tan x is a quotient identity. Whenever you see tan, make it a point that you change it to its identity of sine over cos. Like in this instance, we are solving for identities. We change this to sine over cos. We also had a tan on the previous question. In such cases, you do not have to change it, right? But you can change it where you are dealing with what? Identities in most cases. Plus cos x, let's continue, 1 over sine x. Then how do we simplify this? We do what? The butterfly method, where we just cross multiply the numerator and the denominator and cross multiply this numerator and denominator, and then this times this gives us what? A sine x1 plus sine x, plus this cos, multiply that cos, gives us a cos squared x, divided by, and then we're gonna end with this denominator times that denominator gives us the denominator for this one big fraction, sine x. This is the butterfly method. Essentially, you have two fractions that are adding, or even when they are subtracting, this is what you're gonna do. Take this denominator, multiply it with that numerator, and this denominator, multiply it with that numerator. Then you end by multiplying the denominators so that you can get your LCD. Okay, so this sine times that one, this sine times that sine, it's sine x plus sine squared x plus a cos squared x over, we do not have to multiply this. You'll see why. You'll see why. You'll see why. You'll see why. Alright, so this sine squared x and this cos squared x combined, they are actually an identity. The identity of 1, the squared identity. So here is going to be a 1 over cos x 1 plus sine x equal to. Okay, now this is the reason why I did not want to multiply the sine with that bracket, I mean the cosine with that bracket. It's because of what remains above, right? It's somewhat, this actually looks exactly the same as this. It's actually one and the same thing. If I put the 1 here and bring the sine over here, I'm gonna have a cos x 1 plus sine x. So this is the same as this, so they cancel each other out. I'm left with the 1 over the numerator divided by a cos x. Now you can see that it's the same as the right hand side. Okay. If you have a, of course, if you have a question regarding this question, or you did not understand, or you need some clarity, let's talk in the comment section of this video. Okay, now that we have shown that this identity is actually true, we are now tasked or given a task to solve for x. So from identity to now solving what? An equation. From an identity to now solving an equation. I feel like there should be a mark allocation for this, man. Now it's not fair for 7 marks. Just think about it. All the work we went through, now we have to solve for x, where the x is between 0 degrees and 360 degrees. Okay, so this, they are now saying it's equal to what? 2. Then they say solve for x. It looks somewhat complicated, but because of the identity above is true about this being equal to 1 over cos x equal to 2, this is also equal to that, right? So in order to solve this equation, you would actually have to solve for or simplify the expression on the left hand side, but you don't have to, because it was the identity above. So simplified, the left hand side simplified is now 1 over cos x, divide by 1, cross multiply, then you solve for x. Okay, 1 times 1, that's 1, equal to cos x times 2, that's 2 cos x, divide both sides by 2, you now have a cos x that is equal to 1 over 2. So when solving for trigonometric equations, the idea is to actually isolate the trigonometric ratio on one side of the equation and a value on one side of the on the other side of the equation, right? Then what you do next is getting the reference angle. We're now going to get the reference angle. So we're going to find the arctan of a half. This is what? Cos of a half, which is 0.5. You can even do it this way, man. 60 degrees. So 60 degrees is our reference angle, right? It's our reference angle. Now, since the value, remember that question 3.1.5 in the multiple choice section, now it brings us here again. We now have another trigonometric equation, right? So when solving for trigonometric equations, once you get to this step where you have a trig ratio equal to some value, since the value is positive, right, we want to find out where cos is positive on the cast diagram. Cos is positive where? In the fourth quadrant, as well as in the first quadrant. So it's positive here and here. Okay, so to get our solutions, we would only focus on the quadrants where cos is what? Is positive, and that's the first quadrant. So the first solution we have, it's in the first quadrant. So our x is going to be just equal to 60 degrees. X is 60 degrees because there is no reduction formula where in the first quadrant. So you're just going to take the reference angle as is and put it as your solution for the first quadrant. Then for the fourth quadrant, then for the fourth quadrant, x is going to be equal to 360 degrees minus the reference angle. X is now equal to 360 minus this, it's what? 300. So this is our second solution, which is found in the fourth quadrant. The first solution is 60 degrees. Yes, so this is the final answer for our 3.3. Any questions, leave them in the comment section. All right, now for the final showdown, for this question 3. How do I hide this? Yes, so for the final question, let me drag it downward so that you can see the actual question, the whole question, I mean. Okay, so question 3, it's all about the sine rule, the cosine rule, and the area rule. So it's basically all about the triangular formulas. Okay, so the diagram below shows two wires, AD, here's AD, and AC, here's AC, of lengths 13 and 10.5 respectively, attached to a pole BD. The angle between the wires is 10 degrees. Here it is. And then 3.4.1, calculate the length CD. Okay. In level 2, you learned about the right angle triangle, and you also learned how to apply what? To apply the trigonometric ratios. But now, in level 3, we cover what we call, or we do what we call triangular formulas. These are formulas that we can apply to what? To triangles that are not right angle triangles. You can use the rules to calculate unknown sides as well as unknown angles. If you take a look at this sketch, how many triangles do you see? I see 3. I can see 3 triangles. Let's get a red marker for this. So this is the first one. This is the first triangle. We're going to refer to this one as the red triangle. I also see a blue triangle, the big one here, the big triangle, this one. This is the big triangle. And then we also have the medium one, which is the green triangle. If you study the triangles carefully, you can see that the red one, the green one, is a right angle triangle, as well as the blue one, except for the red triangle. Now, to answer this question, where they want us to find the length CD, it means that we will have to take or use the red triangle to calculate the length CD. So the triangle, let me just say, in triangle ACD, we're going to use this triangle to calculate CD. Alright, so we're going to take triangle ACD to calculate CD, right? Remember, there's 1, 2, 3 rules, but let's scratch out area rule for now, right? It's either you can use the sine rule or the cosine rule to calculate the unknown side CD. But if you know your rules very well, you can see that you have two sides, adjacent sides, that are given and an angle in between. This calls for the application of the cosine rule, where we say the side that is opposite to the given angle, we square it. It's going to be equal to one of the sides that are adjacent squared plus the other adjacent side squared minus 2AC multiplied by AD multiplied by the cosine of the given angle. So this is the given angle, side squared, the cosine of this angle, the unknown side CD squared, equal to this side squared, minus 2 times AC AD, which is this side and this side again, multiplied by the cosine of this given angle. That is basically the cosine rule. Alright, so since I don't know what CD is, I'm just gonna say CD squared is equal to, what is AC? AC is given as 10.5 squared plus, what is AD? 13 squared minus 2 AC, that's 10.5. AD 13 multiplied by cos 10 degrees. Let's take this 10.5 square plus 13 square minus 2 open bracket 10.5 13 multiplied by cos of 10 degrees equal to, so the answer, wow, okay, let me see, it's 10.397484343. So the answer is 10.39748343. CD squared. Take the square root on both sides. So now CD is equal to the square root of 10.39748343. Now the answer is 3.225 meters when rounded off to 3 decimal places. Guys, just make sure that you also read your instructions before writing your exam, right? You'll see that in your instructions it's always written round off all your answers to 3 decimal places. Now 3.4.2, calculate the size of C2, right? Now C2 is one of the angles in the green triangle. And the green triangle happens to be what? Yes, it happens to be a right angle triangle, right? It happens to be a right angle triangle. Now, I'm only given one side. How is this CD going to help now? Okay. All right. I actually don't need the green triangle. You know why? I don't have enough information that will help me to calculate C2. So what I will do, I'm gonna stick to the red triangle and work out what C1 is and use angles on a straight line and calculate C2. So now for 3.4.2, I need to apply now the sine rule. So for the first question, 3.4.1, I actually applied the cosine. Now for the second one, the 3.4.2, we're going to apply the sine rule, right? So the sine of C1, sine of angle C1 over 13 is equal to the sine of this angle 10 degrees, sine 10 degrees over CD. Here's CD, right? So with the sine rule, let's say we have a triangle with vertices A, B, and C, right? And then here you have theta, here you have alpha, here you have beta. Okay, so if you take the sine of theta, you have to divide by its opposite side, by the opposite side of that angle. If you're going to take the sine of this alpha, you're going to have to divide by the side that is opposite to that angle alpha. If you're going to take the sine of beta, you're going to have to divide by the opposite angle, the opposite side of that angle. So just like what I did here with sine C1, I'm going to divide it by the side that is opposite to that side, to that angle. Sine 10 degrees, I'm going to divide it by the side that is opposite to 10 degrees, right? So you want to set up an equation such that only one is unknown. Like I wanted to calculate C1, so it's the only unknown. I do have CD. So sine C1 over 13 is equal to sine 10 degrees over CD. It's what? It's 3.225. Cross multiply, and then we end up with sine C1 multiplied by 3.225 is equal to 13 multiplied by sine 10 degrees. Divide both sides by 3.225. Cancel. We now have a sine 1 degrees is equal to 13 multiplied by sine 10 degrees over 3.225 equal to. So this is the answer. Should I write the whole thing, Mara? Nah, let's just say 0.699939. So okay, 8, right? Then we're gonna calculate C1, and then we're gonna take the arc sine of 0.69998, close bracket. Now C1 in 3 decimal places, it's gonna be 4.44.425 degrees, right? Then our C2 C2 is going to be equivalent to 180 minus the 44.425 degrees, angles on a straight line. So C2 is going to be 180 minus 44.425. This is equal to 135.575, is it? Yes, 575. Okay, this concludes our discussion on question 3 on general trigonometry. Check the description box for more recordings that I did for this question paper, supplementary paper 2 mathematics. Thanks for tuning in, guys. I'll spawn on the next one.